Hola, ¿cómo están? Buenos días, buenas tardes, buenas noches, donde estén. Acá estamos arrancando la tercera keynote que voy a estar reaccionando o viendo con ustedes hoy. Ay, tengo el teléfono con ruido, por lo menos me garantizo que se escucha. Y acá estamos, otro día más. Estamos a jueves, para los que están en Vegas deben estar reventados, a jueves a las 8 de la mañana creo que es. Pero bueno, como uno está en casa, ha dormido, no ha salido de fiesta y está entero. No sé cómo están ustedes, me imagino que siguiendo las noticias. No hubo ningún lanzamiento, al menos extra, fuera de lo que ya vimos ayer en la keynote, así que ha sido un reInvent tranquilo, con cosas muy interesantes, pero sin mucha locura. Y hoy descubrí una cosa, una app que perdí el contacto, el post de LinkedIn donde lo robé, bueno, no lo robé, me gustaría referenciar a esa persona que lo hizo, a ver, vamos a mirar. Porque yo les decía ayer de que ya se están subiendo todas las breakout sessions a YouTube. Y si vamos a YouTube, es muy difícil ver todas las breakout sessions. Están todas en una playlist, pero hay, no sé, vamos a refrescar esta página. ¿Cuántos videos hay? 236 videos. Es un descontrol, re difícil de buscar. Entonces alguien, que no sé si puso en el about o algo, pero no veo dónde está. A ver acá. Martin Damonsky, así que vamos a abrir su LinkedIn para que lo vean, un community hero de República Checa. Creó esta página que se llama Rewatch. Les puse el link ahí en el chat, donde están todas las sesiones y te podés loguear y podés crear como tu Watch Later playlist. Yo ya estuve agregando algunas charlas, todavía no las tengo todas porque no las han subido todas las que quiero ver, pero ya tengo algunas acá y después se hace mucho más fácil poder hacerle clic, la ves y pones remove y pum. Así que me pareció algo para recomendarles porque si no saben qué ver, van a New y acá pueden tener todos los filtros, pueden ver los niveles, pueden ver un montón de cosas y así van eligiendo qué quieren ver. Y si todavía no saben qué ver, yo les hice unas recomendaciones de charlas antes de que empezara Reinvent, que son las charlas breakout sessions, porque Marcia no fue a Reinvent este año, donde recomiendo como 27, 30 breakout sessions. Y ahora apenas se suban, ya voy a actualizar este blog post con links para que puedan ir y verlas directamente. Muchas todavía no están subidas. Y bueno, así que con esto pueden buscar el título en la página esta que creó este Hero. Mira, ahora les puso el código acá. Algunas lo tienen para que el search sea más fácil. Y buenísimo. Así que ya tenemos una forma más fácil de ver nuestras charlas de Reinvent. Hablando de charlas y de Reinvent y cosas así, me gustaría probar el sonido, que esté todo funcionando bien. Así que ahora voy a cargar algo. Vamos a cargar una de las charlas de Reinvent y vamos a probar a ver cómo se escucha. Vamos a ponerla acá en la tab. Y vamos a probarlo. Me lo dicen en los comentarios acá en el chat si se escucha bien. Vamos a hacer script capture y vamos a darle audio a esto.
Taking you from vision to victory. I'm Brad Savenko. I'm in professional services with AWS and a team called Expert Services, where I run the migration and modernization team.
¿Me cuentan
we
si
do some of the
escuchan?
largest migrations in the world with some of the largest household names that many of you may be heard of, and perhaps some of you are in the room today. I'm joined by Oscar Rodriguez, who leads the team. We have domain practices across migration and modernization, data, enterprise transformation and supply chain. And together we're changing the world with some of these customers that I speak about. Speaking of which, we've invited Ashish Shekhar back.
¿Y se escucha o no se escucha? ¿Me ponen en el chat, porfis? Esta charla no tengo ni idea qué es. Elegí una muy al azar. Pero ahora me imagino que en 5 minutos estará por empezar la keynote. Sí, se escucha bien. Gracias, Gustavo. Estará por empezar la keynote, así que es bueno saber que se escucha para no tener que andar peleando con las configuraciones. ¿Qué les iba a contar? Me gustaría saber de dónde están escuchando, qué hora es, qué hacen mientras escuchan. Yo siempre que veo las keynotes me tomo un tecito, acá dentro hay un tecito calentito, porque estoy en Helsinki, hace frío, son las 7 de la tarde, está oscuro desde las 3, medio lloviznando, hermoso tiempo, entonces me apetece siempre un tecito hasta ahora. Aparte, yo hace muchos años que vivo acá, soy muy nórdica y para mí las 7 de la tarde es la hora de cenar, entonces me da hambre y bueno, me ayuda. Ay, estás en Cancún, qué envidia. Ay, ay, qué bueno, Gustavo, desde Cancún. Ojalá uno pudiera estar ahí. A mí me faltan todavía, no sé, una semana y algo para irme a Uruguay, que es de ahí desde donde soy, a empezar a disfrutar el verano. Ay, Diego, México, otro más, qué bonito. Así que ustedes están en la mañana, como la gente en Las Vegas, que creo que son las 9 de la mañana para ellos cuando empieza la keynote, si no me equivoco. Y esta keynote, no sé si conocen un poco la dinámica, como es, suele ser una keynote muy técnica. No suele haber lanzamientos en la keynote de Peter DeSantis. Generalmente él la hacía solo. Este año mezclaron a Peter DeSantis. ¡Ay, alguien de Uruguay! Ahí estaré en unos días. En esta keynote tenemos a Peter DeSantis, que es el VP de como infraestructura. Y después tenemos a Dave Brown, que es el Vice President de Compute. Y Machine Learning, ahora lo mezclaron todo junto. Y me imagino que entre los dos lo que van a hacer es dar una charla muy orientada técnica, entrando, los dos son muy, muy técnicos, entrando en el hueso de AWS. Muchas veces Peter DeSantis en keynotes anteriores ha explicado cómo funcionan data centers, cómo funciona Graviton, cosas que están súper, súper interesantes. A veces tienen clientes, bueno, generalmente siempre hay clientes que muestran, suelen ser clientes más técnicos. Entonces, si vemos las keynotes, las 3 keynotes que vamos a hacer en live stream, tenemos la de Matt, el CEO, que suele ser muy negocio, muy alto nivel, con muchos lanzamientos. Después el de Sami, que suele ser como muy orientada técnica, pero orientada a la parte más de desarrollo, de Machine Learning. También está la keynote de Bernard, pero son la 1:30 de la mañana. Para mí, a mí dormir me gusta mucho. Entonces esa no la voy a compartir vivo. Espero que la vean los que puedan a una hora razonable. O si no, vean el replay, como voy a hacer yo. Y la de Bernard suele ser una keynote orientada a developers, también sin muchos lanzamientos, pero muy técnica. Se suele ir, es una de mis keynotes favoritas, pero una pena que es una hora horrible para mí. Suele ser una keynote que se suele hablar mucho de desarrollo, de buenas prácticas de software, de DevOps, así que una recomendación muy buena para ver. Y esta keynote suele ser muy técnica, suele ser a bajo nivel, hablar de infraestructura, de procesadores, de construcción de datos, centro de datos y quién sabe qué, porque ahora van a mezclar a estos dos señores y no es una keynote muy larga, va a ser una keynote, en el calendario está marcado como 1:30, así que yo imagino que va a durar 1 hora y algo. Y acá veo, mira, ya en la página web podemos ver los clientes que tienen, porque están los speakers. Está un señor que es de 12 Labs, no es 11 Labs, es 12 Labs, que es el CEO y founder de 12 Lab, que es a leader in video understanding AI, así que algo de machine learning y entendimiento de video. Después está Payam Misarshidi, que es de Apple, Vice President de Cloud Systems y Plataformas de Apple, así que nos contarán algo de la partnership que tiene Apple con AWS en la parte de chips, que es bastante grande. Y después está Dean Leitersdorf, la dislexia me mata para pronunciar apellidos, que es el CEO y co-founder de Dcard, que ¿qué hace Dcard? También habla de principios de computación distribuida y bla, 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 pero no me cuenta qué hace la empresa o de qué viene a hablar. Pero bueno, tiene pinta de ser una persona que sabe mucho de procesadores y de computación y de machine learning. Así que va a ser muy técnica. Vayan preparándose sus cafecitos, tecitos, No creo que escuchemos IA o tanto como veníamos escuchando en las otras keynotes, pero seguramente lo mencionen ya que Dan Brown es el VP de Machine Learning, pero va a ser una keynote muy, muy interesante. A ver si arranca pronto porque estaba marcada para las 7 y son las 7. Bueno, al menos, mira, ahí empieza. Vamos a poner aquí. No, aquí. ¡Arrancamos!
Please welcome the Senior Vice President of Utility Computing at AWS, Peter DeSantis.
A ver si andan los subtítulos. Ayer para la de Swami andaban bárbaro.
Good morning. Welcome to the penultimate day of reInvent 2025. Thank you all for your participation this week. It's been a great week. I hope you had as much fun as we did. Now, I expect many of you probably came this morning expecting to see Werner. I get it. We switched things up. You've been busy all week. So I came prepared for this. If you just direct your attention to the screens at the side. Hopefully this feels a little more familiar. For those of you that don't know me, I usually do the Monday night keynote. Now I asked about beer, but apparently you can't do beer at a morning keynote. Makes sense? But I apologize. I'm more interesting after a couple beers. Okay. If my transition didn't help you get a fix, you can catch the real Werner this afternoon at the closing keynote. As he says, he'll be the last thing standing between you and the party. Now, I'm not going to spoil anything, but Werner tells me he's going to talk about what this AI transformation is going to mean for us developers. And that got me thinking, what is this AI transformation going to mean for the cloud? Well, I think it's pretty obvious this new generation of AI-driven applications is going to drive a ton of innovation in infrastructure. And that's exciting for us. But I want to start out talking about what's probably not going to change. And these are the things that we've been focused on delivering since the first days of AWS. The things that we really care about. I would argue these things are maybe even more important. These are the core attributes of the AWS cloud. And delivering on these attributes has guided every service, every API, every technical decision that we've made and continue to make. We think about these things a lot. And we make big, deep, long-term investments to support these attributes. take security. As you probably already know, it's not just the good guys that are getting more productive with AI. The bad guys are using the same tools to attack your products, your customers, and your infrastructure. So it's never been a more important time to know that your cloud provider's first priority is security. Or, right there behind security is availability. And the sheer size and scale of the applications that are being built right now demand performance from security, or from databases, analytics, networks. So there's never been a better time to build on a cloud that's been tested running the most demanding workloads of the last decade. And what about elasticity? One of the most important things about the cloud is it takes away capacity planning. It wasn't long ago that one of the first things startups would need to do is plan and provision their infrastructure. What a complete waste of time. And worse yet, there's no right answer to the question, how much capacity do I need? If you plan too little, you miss your big moment. Plan too much, you might not afford to be able to get to your big moment. Now today, capacity planning is likely something that you don't do at all. And that's a great thing. AWS is ready to scale when you need us. But we're not done here. AI workloads have led to an unprecedented increase in the demand over the last few years. And we see this as an opportunity to take the innovations that we've been working on for the last couple of decades and apply them to these new technologies. Our goal is to give you the same elasticity that you get from a service such as S3 with your AI workloads. And you're going to hear a little bit more about how we're doing that this morning. And that brings us to cost.
El tema favorito de todos.
It will transform every aspect of our life. But one thing that anyone who's put an AI application into production knows is that AI ain't cheap. It's really, really expensive to build these highly capable models, and more expensive still to run the massive amount of inference that we need to transform our lives with these models. You see almost daily headlines of the tens of billions of dollars that are being invested in data centers, power, and capacity to support this AI transformation. And AWS is investing massively in this expansion as well. But we're doing something else. We're investing deeply in lowering the cost of building these models and running these workloads. You've heard a little bit about Trainium this week, but later this morning, we'll share a bit more about how we're building Trainium to meaningfully lower the cost of these workloads.
Es lo que le decía, que van a hablar de chips.
When we launched AWS almost 20 years ago, I think the attribute that most contributed to the success of the cloud was agility. It became quickly apparent that the companies who adopted the cloud were able to move faster than the companies that stayed on premises. They were able to innovate faster. They were able to deliver value to their customers faster. They were able to grow faster with fewer issues. And most importantly, they were able to pivot faster. That's agility. That's the magic of the cloud. You can launch, optimize, pivot quickly. Now, doesn't that sound exactly like what you're going to need during this AI transformation? There's a lot of ways that AWS helps you be more agile. But one of the ways is by making sure that you have the right tool for the job. Whether you're a startup inventing something new or an enterprise.
Como siempre, AWS dándonos todos los Legos para que nos armamos nuestra casita Lego.
An accident. It's a deliberate choice that we make year after year to keep investing in new services and new capabilities and new ways for you to build. Because we believe that when we remove constraints, when we give you every possible building block, that's when the real magic happens. That's when you can stop asking, can I build this? And start asking, what shall I build next? And the really exciting thing is the power of these building blocks is only going to be magnified through agentic development.
Ahora es momento de poner el hype.
AI are the exact same things that we've been obsessing over for the last 20 years. But these capabilities don't happen by accident. You don't just wake up one day and say, I want better security or lower cost. These attributes come from a very deep commitment and investment over time. Let me give you my favorite example. I'll set the stage. It's 2010, a few years after we launched EC2. By this time, it was abundantly clear that customers loved EC2 and they wanted to run all sorts of workloads on it. And for the most part, they could do it. Our performance was just fine. But for a few of the most demanding workloads, we faced a challenge. While our systems delivered great performance most of the time, we'd see these frustrating outlier latencies, or something we call jitter, where performance would suddenly drop off just a few hundred microseconds, but enough to impact these applications. These excursions came from the virtualization layer. Now, virtualization was one of the key enablers of EC2, and it works really well. But common wisdom at the time is that virtualization would work fine for less demanding workloads, but it could simply never deliver the performance of a bare metal server. But that wasn't compatible with our vision for EC2, where we wanted to run every workload. So we got really focused on fixing the jitter problem. Basically, we aimed to put jitter where it belonged. Week after week, our engineers would deep dive into the data and tackle these outlier latencies. We made impressive progress with optimizations and achieved results, frankly, that many people didn't think we could. But eventually it became clear we didn't have a path to bare metal performance. There was just always going to be some virtualization tax. So, of course, you have to change what's possible. And that's where the Nitro system came in. Nitro is our AWS-designed custom silicon. It moves virtualization off the server and onto dedicated hardware. And this allowed us to completely eliminate the jitter problem and actually get exactly the same, in fact, better performance than bare metal.
Think different.
Nitro also improves security, delivers higher performance, and allows us to support a wide range of instance types. The Nitro system is an excellent example of the deep investments that we've made, in this case, actually building our own chips, to enable these key product attributes that I just talked about. Now, for those of you that have joined me on Monday night, you're probably thinking I'm about to get into a deep CS lesson on how Nitro works. But I have something better this morning. This is one of my favorite textbooks from my undergraduate degree. It's an excellent book, and it's an undeniable part of the CS canon, written by a couple of luminaries in our field. This is an image of my actual textbook from undergrad, which I still have. Now, this is the second edition, and it turns out that's a bit dated at this point. The industry's changed a lot. In fact, the 7th edition of this textbook just recently came out. And this edition actually has a section that covers the Nitro system. How cool is that? You can now actually learn about Nitro and Graviton in this CS textbook. And to celebrate, we're going to give away some copies of this book this morning. Now, I'm going to put a QR code up on the screen in a second. If you scan it, you can get a copy of this book. The first 1,000 people here in the room can take this book home. If you're lucky, ready? Here we go. The QR code's not showing on my screen. It's up there. Okay, if you're lucky enough to snag a copy, you'll be able to pick it up at the...
No hay copias virtuales.
Example of the deep investments we've been making for the past 20 years. It's also the reason that AWS started building our own chips, which now include Graviton, our custom AWS server process, and Trainium, our AI chip. So to start off this morning, we'd like to tell you more about Graviton. And to do that, please welcome to the stage Dave Brown.
Acá viene Dave Brown, a ver qué nos cuenta. El VP de Compute. Bueno, nos va a contar de Graviton, ya nos dijeron.
Well, as Peter mentioned earlier, Nitro changed what people thought was possible in the cloud. It showed that if you could control the silicon, the hardware, and the system architecture, you could get performance and efficiency gains that were simply not available using commodity hardware. And as we spent more time with ARM inside the Nitro system, a natural question emerged. If custom silicon could improve network and storage so meaningfully, why couldn't we apply that to compute? And so we took a step back and asked, well, what if a server processor, what would it look like if we designed it specifically for cloud workloads? Not adapted, not repurposed, but built for the cloud from the ground up. And that's where the Graviton processor came from. A brand new design based on delivering the best price performance for workloads that customers run every day in the cloud. And across industries, organizations are getting better performance and lower cost with Graviton. Adobe is cutting emissions by 37%. Epic Games is powering massive low-latency global gaming workloads. And Formula One of my favorite sports, is running simulations at 40% faster. Pinterest is lowering costs by 47%, and SAP has seen a 35% performance improvement with their SAP HANA Cloud. Now, these aren't just demos. These are production systems running faster, cleaner, and cheaper with Graviton. And we're seeing the same enthusiasm from our software partners. They're tuning compilers, reworking runtimes, optimizing libraries, and building native support across their platforms for Graviton. And they're leaning in because they see clear performance benefits, cost benefits, and a strong long-term architecture. And industry collaboration around Graviton continues to grow and mature. Now, delivering the best price performance in EC2 takes attention at every layer. It starts with building great performance into our silicon, but it also comes from how we build and operate the systems around that silicon. Because we design both the processor and the servers, we can optimize across the full stack. And that includes something customers don't often think about: cooling. This is the traditional cooling approach that most processors use. You have the silicon, and then a thermal interface material, or TIM, and then a protective lid, and then more TIM, and then the heatsink. Now, it's reliable and easy to manufacture, and it's been the industry standard design for decades. But let's dig in a bit here, because the physics is fascinating.
Estas keynotes siempre son así.
It's straightforward.
Entrar al detalle, súper
And
interesante.
the thermal path slows heat movement. So more resistance leads to higher junction temperatures, and higher temperatures increases leakage, and higher leakage increases power consumption. It's an area where the inefficiency can stack up really, really quickly. Now, traditional CPUs use this design because they must support many systems, many form factors, and many cooling solutions. And that lid provides a stable interface. But since we control the entire system for Graviton, we had the opportunity to think differently. So instead of following the traditional model, we designed a direct-to-silicon cooling solution. We removed the lid, along with a layer of TIM, and that reduced the resistance and allows heat to move more efficiently. Now, it requires precision manufacturing and carefully selected materials, but the result is meaningful. Our fan power drops by 33%. And remember, we're only able to do this because we control the entire stack. Now, improving system efficiency is just one part of delivering great performance. The silicon itself has to keep getting better generation after generation. And chip development is both iterative and long-term. Each generation of Graviton expands the set of workloads that we can serve. And every time a new set of workloads comes along, we learn where the next set of bottlenecks are. And that learning feeds directly into the next generation. It's a continuous improvement cycle. Each Graviton processor builds on what came before it and continues to push the architecture forward.
Nuevo Graviton. ¿Vendrá?
For real-world application performance. And with Graviton 3, we saw that the L2 cache misses were having a notable impact on real-world workload performance. The cache is one of the most important predictors of CPU performance, and so it became a real priority area for us. When a core needs data, it checks the cache first. Cache is small and extremely fast, and is designed to hold frequently accessed data. And when that data isn't available in the cache, the processor must go all the way out to main memory, which is much, much slower. Now, modern CPU architectures use a three-level cache hierarchy: L1, L2, and L3. L1 is the fastest, L2 is larger but slightly slower, and L3 is larger still and shared amongst the cores. Now, missing all three levels of cache means you have to go to the DRAM, which can take up to 100 nanoseconds. That's a long, long time in CPU cycles. And this is why we love big caches. The more data you can keep close to the core, the fewer slow memory trips you have to take. So with Graviton4, we doubled the size of the L2 cache from 1 megabyte to 2 megabytes per core. And that was one of the contributors that led to Graviton4 delivering up to 30% better performance than Graviton3. And as you'd expect, doubling the L2 cache significantly reduced L2 cache misses. But designing a CPU is always about trade-offs. So in Graviton4, we also increased the core count by 50% and the L3 cache by about 12%. And that was the right balance for the scale-up workloads that we wanted to serve at the time. But with more cores sharing the relatively smaller increase in L3 cache, each core ended up with less L3 cache than before. And that's why we saw an increase in L3 cache misses. And these are the kinds of trade-offs that you're constantly evaluating when you're designing silicon. And also, we made a major architectural change by adding a coherent link between two CPUs. And this allowed us to deliver up to 192 vCPUs for databases and large analytical workloads.
Una
But
locura.
linking processors introduces new latency paths. And when a core needs to access memory on the other CPU, the request has to move across that interconnect. And that adds latency, extra protocol overhead, and sometimes even queuing. And in certain scenarios, it can take up to 3 times longer. And so we asked whether we could deliver 192 cores with uniform, fast access to memory and more cache, all in a single package. And today, we're excited to introduce Graviton5. The Graviton5 delivers 192 cores in one package and provides over 5 times the L3 cache of previous generations. That means each core now gets up to 2.6 times more L3 cache. And that leads to better overall performance and better consistency.
Mejor Graviton.
And all of this comes together in our preview of M9G instances powered by Graviton5. M9G delivers up to 25% better performance than M8G and offers the best price performance in EC2 today. And we're already seeing incredible results from some of our early customers. Airbnb has seen up to 25% better performance. Atlassian is seeing 20% lower latency. Honeycomb.io is seeing 36% better performance per core. And SAP, well, SAP has seen an incredible 60% better performance on their OLT queries for SAP HANA in the cloud. Now, these are significant real-world improvements, and they represent a major generational step forward. And now I'd like to bring up a guest who has been influential in shaping how developers build on AWS. Please join me in welcoming the Vice President of Cloud Systems and Platforms at Apple, Payam Marashidi.
A ver si hablan de Apple en AWS.
We're driven by the idea that the products and services we create should help people unleash their creativity and potential. We build some of the largest internet services on the planet, and many of them run on AWS. My team works on services such as App Store, Apple Music, Apple TV, and podcasts, the services billions of you use every day, and what I like to call the fun stuff. We also build the underlying cloud infrastructure across AWS and our own data centers. That makes it all possible. Wow, that's a lot of technology power on one slide. And not just the kind you see in the F1 movie, but the kind that powers experiences for billions of users all over the world. And that's why we're always looking for ways to optimize how we develop and deliver our services. Now, many of you are navigating a hybrid world, balancing your own infrastructure with the power of AWS. And let me tell you, at Apple, we get that. We face the same pressures and challenges you do. We're in a massive operation. We're tackling the same problems: scalability, performance, and reliability. And we're solving it with AWS. Like many of you, my journey as a developer started with coding in C. And then in 2002, when I joined Apple as an engineer on the original iTunes store, we're a Java shop. We're a small team with big dreams of how to change how the world consumed music. Over the years, we mostly stuck with Java, and when we needed more performance, we used C++. But it was, well, cumbersome to develop and even more difficult to support at scale in production. And as our services scaled, we also faced new coding challenges. The tools we had weren't always up to the task. Now, around the same time, Apple's own operating system team was creating Swift. Initially, the premier language for developing the apps you know and love on your iPhones and Macs. Swift's performance, modern design, and built-in safety features revealed its potential for server-side development. Now, I know, introducing a new language, especially on the server, can raise eyebrows. But with Swift, a single developer can often handle both client and server-side. You can turn client-side logic into a library, run it server-side, maintaining a single code base. The power of having the same logic on both client and server is immense, and I think you'll find it incredibly valuable for your teams too. Today, Apple uses Swift to power everything from Apple Silicon all the way up to the pixels rendered on your screen. Swift is easy to learn, scales beautifully from embedded systems to massive architectures, and is perfect for building distributed services or complex system software. Apple is processing billions of requests per day with apps built in Swift running directly on AWS Graviton. We've seen a 40% increase in performance,
Básicamente,
and a 30%
usan la nube
reduction
de
in cost by
AWS.
rewriting core services in Swift and moving workloads to Graviton. The transition from x86 has been seamless, with a near drop-in replacement for Java thanks to Graviton. Apple moved to ARM more than a decade ago to power our devices. And now we're seeing the same value moving to ARM-based Graviton to get more out of our infrastructure. Higher throughput means fewer instances, lower costs, and a smaller footprint, a win for our customers and for the planet. A great example is our spam detection feature in iOS 26. We use Swift on AWS Graviton to scale the compute-heavy operations behind the service that helps us detect suspicious phone numbers while maintaining privacy for hundreds of millions of users. In fact, the Messages app running on your phone, the spam detection feature running on the server are using the same language and scaling seamlessly. This feature is built with homomorphic encryption using a Swift library that we open sourced, enabling private and secure computation of data without the server ever decrypting it. This allows us to handle massive volumes of data and protect billions of users with incredible speed. In an era of vibe coding and AI development, the languages we choose are critical. Swift's legibility and safety make it a great addition to your AI toolbox. 10 years ago this month, we open sourced Swift and shared this incredible language with the world. And the response has been remarkable. Today, Swift is available on Linux, Windows, Android, and more. It's embraced by a vibrant community, and millions of developers globally are building apps from everything from devices to data centers. It's time to consider Swift for your next project. Check out swift.org for a language that's fast, expressive, and safe, running on the next generation infrastructure of AWS and Graviton. And in case you haven't heard, there's now a native Swift toolchain available for Amazon Linux, the first distribution to have an official package. To the AWS and Swift on Server community, thank you for your vision and your partnership. I'd also like to thank Dave for having me here today. We can't wait to see what you all create with Swift on AWS Graviton. Thank you.
Así que no hablaron de Apple Silicon, pero de cómo funciona
Really impressive.
en AWS.
Now, one of the biggest transformations that the cloud brought was how quickly companies could move. The developers stopped waiting on hardware and instead could spin up resources in minutes and even seconds. And that speed, the ability to experiment, to iterate, to fail fast, and hopefully succeed fast, is now essential. And over the last 20 years, we've done more than just bring you faster computers. We've given you, our customers, faster building blocks and tools that remove the undifferentiated heavy lifting so that you can focus your workloads on time and energy on what truly differentiates your business. Now, I want to take us back to 2013, a moment when a very small group of engineers within AWS asked a question that sounded almost impossible at the time. What if a developer could just hand their code to AWS and have it run?
Lambda.
No servers, no provisioning, no capacity planning, no scaling. And the engineers that came up with this idea, well, they weren't even on the EC2 team. Because the EC2 team, myself included, was deeply focused on servers, instance types, armies, order scaling groups, load balancers, and of course, putting jitter where it belonged. And when you're focused on servers, you don't naturally ask the question, what if there were no servers at all? But that was the breakthrough. The point wasn't to make servers simpler. It was to remove servers from the experience entirely. And you see, at the time, the S3 team was handling millions of thumbnails, profile pictures, product photos, social media images, all pouring into buckets across the S3 fleet. And every time a new image arrived, a lot of work had to be done. It had to be resized and cropped and watermarked, whatever the application required. And to do that, customers had to run fleets of EC2 instances. And they'd pull the image from S3, they'd process it, and they'd push back the results.
El ejemplo
And
más
those
típico de
servers,
Lambda.
the scaling logic, the orchestration was all managed by the customer. And it was a ton of undifferentiated heavy lifting, triggered every time a new object arrived in S3. And the S3 team had an elegant insight. If they attached a little bit of compute directly to the storage layer, they could run a small function the moment a new object landed. No fleets, no data shuttling, and no orchestration. Upload an image, compute runs, thumbnails appear. And that simple idea, bringing compute to data, became the seed of something much, much larger. And as the concept evolved, we realized that it wasn't just about those thumbnails. This was a new application model. Customers didn't just want to run the logic when a new image arrived. They wanted to react to database events, log systems, IoT messages, API calls, any event that the system may introduce. And when we launched Lambda in 2014, it changed the landscape. For the first time, developers didn't start with servers. They started with code. Lambda handled the execution, the scaling, the availability, and the fleet, and you only paid when your code ran. And Lambda wasn't just a new service, it was a new mindset. And as customers immediately embraced it, startups moved faster. Enterprises modernized workloads that had been stuck for years. Event-driven architectures, real-time processing, data pipelines.
Más de 10 años de Lambda ya, muy loco.
And a decade later, Lambda still remains the fastest way to go from an idea to production. And customers love it because it removes so much of the operational weight. And of course, as usage grew, people pushed Lambda into new territories. So we kept expanding it. More runtimes, container support, VPC networking, predictable performance options, snap start, and function URLs, all without adding any operational weight. But as usage grew even further, customers continued to push Lambda into new territory. And they wanted access to the latest EC2 technologies. They wanted predictable performance at very, very high scale. They wanted more network throughput. They wanted sub-millisecond latency. And they didn't want to trade away any of Lambda's simplicity to get those things. And this created an inflection point. Well, a couple of years ago, we brought the Lambda and EC2 teams under one organization for the first time ever. And when we did that, these two groups, one rooted in servers and one rooted in serverless, started looking at the entire space of compute together. And we began to think of compute not as rigid boxes, EC2, containers, and serverless, but as a spectrum of choices. And that naturally led us to a deeper question. What is serverless?
La pregunta
Is
que
it
nos
no
hacemos
servers?
todos.
Is it no operations? Is it don't make me think about the infrastructure? Is it just run my code? Well, customers were telling us something clear. We love Lambda because we don't have to manage infrastructure. But we want control over the performance. And we do want access to the hardware that we need. And so we asked ourselves another bold question. Could we preserve everything that customers love about serverless, the simplicity, the automatic scaling, the operational model, while giving them the performance choice of EC2? And this week, we're thrilled to answer that question with Lambda Managed Instances. Lambda Managed Instances elegantly bridges the gap between serverless simplicity and infrastructure control. With Managed Instances, your Lambda functions run on EC2 instances inside your account, and Lambda manages the provisioning, patching, availability, and scaling.
Y espero que maneje las VPCs, porque...
Lambda handles the rest. It's the next evolution of serverless compute. And the best part, your existing Lambda functions continue to work as is. No re-architecture, no code changes, and no operational burden. You get the performance characteristics of EC2 with the developer experience of Lambda. And we think this opens the door to workloads that historically lived outside Lambda: video processing, ML pre-processing, high throughput analytics, and I'm sure there are many, many more. Lambda Managed Instances isn't a departure from serverless. It's an expansion of it. It brings more choice, more performance, more capability to customers without adding any operational weight. You see, serverless was never about the absence of servers. It was always about the absence of server management. It's about removing the heavy lifting so developers can focus entirely on their code and their business logic. And with Managed Instances, we're pushing that vision forward, giving builders the power of EC2 with the simplicity of Lambda and letting them move faster than ever before.
Este es mi top one launch
Now,
para probar cuando
over the
termine
last year,
Reinvent.
We've seen a major shift in the types of workloads that customers are running. Inference has obviously moved to the center, and it behaves very differently from traditional compute patterns that we've been optimizing for over the last 2 decades. And as we dug into these workloads, it became clear that the elasticity that customers rely on in the cloud doesn't automatically transfer over to inference. And so we've been focused on how do we deliver that same flexibility, responsiveness, and efficiency that customers expect from AWS, even in a world where demand can spike instantly and the cost of getting it wrong is incredibly high. And to understand why inference is such a hard problem, you have to look at what happens inside a single inference request. Now, this is not just take text in, get text out. It's a 4-stage pipeline: tokenization, prefill, decode, detokenization. And each stage stresses the system in different ways. And tokenization breaks the input into tokens that the model can understand. Prefill processes that full prompt and builds the key value cache that the model will use during the decode stage. The decode generates the responses one token at a time, guided by that key value cache. And then detokenization turns those tokens back into a language that we can understand. And at any moment, you're running workloads that are CPU bound, GPU compute bound, memory bandwidth bound, and latency sensitive, all at the same time. And some requests are tiny, others involve huge documents, some must return immediately, and others can take their time. And the resource profile of a single request changes dramatically as it moves through this pipeline. Now imagine doing all of this at global scale. Thousands of customers, millions of requests, dozens of models, each with different shapes, sizes, and urgency. It's a completely different scaling challenge. And to do it well, you need an architecture that can adapt in real time. Now, if you were building an inference service from scratch, you might start with an architecture that we all know, a load balancer and a fleet of accelerators. And that model works well for many applications. It's a proven and effective pattern for traditional web services. And when we built Bedrock, we started with some of these proven patterns, and they served you well. But as models evolved and usage grew, it became clear that inference needed a different architecture. So we went back to the basics and asked, if we were designing an inference service today with everything that we now know about running real customer workloads at massive scale, what would it look like? And that's what's led us to Project Mantle, a new inference engine that now powers many of Amazon Bedrock's models. And one of the biggest insights was that not all inference requests have the same urgency. And so instead of AWS guessing, we wanted to allow customers to tell us. So we launched Bedrock service tiers, allowing customers to assign their request to one of three lanes. Priority for real-time, latency-sensitive interactions, the standard for steady and predictable workloads, and flex for background jobs where efficiency matters more than speed. And this lets customers optimize what they care about, and it lets us allocate resources more intelligently. And the result is consistent low latency for priority workloads while still driving optimized performance across everything else. And the second big challenge that we addressed with Mantle was fairness. In a shared system, one customer's burst shouldn't degrade the performance of others. And Bedrock solves this by giving each customer their own queue. Your performance is determined by your usage, not someone else's. And if another customer spikes, it affects their queue, not yours. And because Bedrock learns your typical usage patterns, it anticipates how much capacity you're likely to need and ensures that it's available when you need it. And this combination of queue isolation and adaptive capacity sharing gives customers much more predictable performance, even under heavy load. And when you put all this together, prioritization, fairness, smarter batching, better scheduling, you get significant gains. Latency becomes more consistent, throughput increases, utilization improves, and the overall system becomes more resilient. But to make this architecture fully reliable, especially for long-running requests, we needed one more component, a durable record of work happening across the fleet. And we call this Journal. The Journal already powers services like DynamoDB and S3 today,
Dynamo.
and it's a highly reliable and durable transaction log. Inference requests can run for a long time. And if something fails, whether that's a hardware fault or a networking issue or maybe just a retry, you don't want to restart the entire request. That wastes compute and increases latency. Now with Journal, Bedrock continuously captures the state of each request. If something goes wrong, you can resume exactly where you left off. And this makes the system far more fault-tolerant, and it also enables advanced scheduling strategies that weren't possible before. And one of those advanced scheduling strategies is fine-tuning. But fine-tuning is super compute intensive and can take hours. Traditional systems require separate training environments, separate schedulers that often sit idle waiting for load. Well, on Bedrock, fine-tuning becomes just a long-running job. If a surge of real-time traffic arrives, the fine-tuning job pauses. And when that surge subsides, it resumes right where it left off. And this now gives customers access to incredibly efficient fine-tuning right within Bedrock, without having to manage training clusters or worry about wasted compute. And as we redesigned the inference engine, we also raised the bar on security and privacy. And as Nitro was done and transformed EC2 by creating a secure, isolated environment for compute, the Bedrock integrates confidential computing to protect model weights and customer data during inference. Data always is encrypted, and operators can't access the environment. And customers get cryptographic assurance that their requests ran in a verified, and trusted place.
Eso es muy
Now, for
importante.
organizations with strict privacy and compliance need, this is a huge step forward. And because we have a strong, consistent, reliable foundation, we can integrate it deeply with the rest of AWS. We've added tool calling support, so your model can invoke Lambda functions for real-time data directly from Bedrock. We've added support for OpenAI's Responses API for long-running jobs. And we've integrated with IAM for permissions and CloudWatch for observability, all the things that enterprises rely on to run their most important workloads. This isn't just about model hosting. It's a fully managed, production-ready platform for generative AI. And everything we've built in Bedrock reflects what we've learned at operating services at massive scale for over nearly 2 decades now. Inference is a new kind of compute. It has its own scaling patterns, its own constraints, and its own requirements. And Bedrock gives us, and you, our customers, the foundation to run those workloads reliably, efficiently, and securely. And behind every API is a sophisticated engine doing scheduling, fairness, resilience, and performance. So customers can stay focused on building. You see, that's what we do at AWS. We take on the hard problems, we solve them, and we give customers the tools that they need to invent the future. And with that, let me hand it back to Peter.
Bueno, aprendieron un poco más hoy en día de cómo funcionan algunas cosas dentro de AWS. A ver qué cuenta Peter. Ya debe estar por terminar, me imagino, en media hora o menos.
Now, I know Dave talked about innovating faster already, but we like innovating, so I'm going to talk a little bit more about that. One of the ways that we like to innovate faster is by giving you access to important new capabilities across our broad range of services. And I think a great example of this is the work we've been doing to enable vector search across AWS. Now, this is a picture of Smokey, or Smugs, or Smug Mug, as he likes to be called. You can see this isn't just a picture of Smokey, and when we look at it, we don't just see pixels. We see physical attributes, bat ears, big tongue. We also see that expression that says, I know what I did, I don't care. Your brain processes all these concepts and ideas simultaneously, and it understands the relationships, and then it connects it to other things. Perhaps you're thinking about your dog, or perhaps you're thinking about that messy eater you sat next to at dinner last night. These associations are sometimes strong and obvious, sometimes subtle. That's what humans do. And vectors allow computers to work the same way. The simplest way to think about a vector is a data point that places it in mathematical space. In our contrived example here, I have 3 dimensions. One represents color, another represents size, and another shape. And you can see now that you can place images or ideas on these 3 axes. Now, the exact location of where things get placed is not so interesting. What's interesting is the relative location of the vector to other vectors. Very different objects, like Christmas ornaments and apples or tennis balls and limes, might end up close together. And it's these associations that are interesting in a vector search. Of course, what we have here isn't going to reveal anything particularly interesting, but that's because we have a very simple, contrived example. In the real world, vectors are far more than 3 dimensions. In fact, a rich vector encoding space today might have 3,000 dimensions. You can see we struggled to illustrate that here. And each dimension isn't something as simple as size or color. It's actually an undefined concept entirely, something itself generated by AI, a special kind of AI called an embedding model. Now, you train an embedding model on lots and lots of data, and the model itself starts recognizing patterns. It learns about different types of dog ears and different shapes. And with enough data, it learns to cluster these objects together in that mathematical space, sometimes in obvious, but other times surprising ways. And so, for example, you might be wondering, well, what do we do with these vectors? Well, as I said, the most interesting thing about vectors is when you search them in a database. So this is where Unlike a traditional database that just stores rows and columns, a vector database is built specifically to find nearest matches to these vectors. So you encode your query, and then it finds objects in the database, other vectors that are close to that. And when you, so in our example, all the French bulldogs might be clustered in one place, and all of the other dogs might be clustered nearby. And cats, I'm not sure where the cats are clustered, who cares? But maybe the ones that like to destroy their toys are next to the French bulldogs. All right, so let's look at what vectors can do in the real world. Think about all the data your company has right now. Your institutional knowledge isn't organized into rows and columns that can be inserted into a database. It's buried in PDFs. It's captured in recorded video calls. Maybe there's some pictures of whiteboards that people have written down. It's scattered in documents across dozens of systems. And the challenge probably isn't that you don't have the data you need. The problem is you can't find the data you need. And now you might be thinking, well, creating a vector database might be a great way to find that database. And that's true. But unfortunately, there's a challenge. Existing embedding models are highly specialized to handle certain types of data, images or text. And so if you want to benefit from the wealth of unstructured data you might have, it means you likely have to combine models. But the catch is you can't really combine models because you can't search vectors across different embeddings models because those abstract dimensions that we talked about likely hold entirely different concepts. So this is precisely the challenge that we set out to handle with the new Nova multimodal embeddings model. Now, this is a state-of-the-art embeddings model that supports text, documents, images, video, and audio. And it converts all of these concepts into a shared vector space, creating a unified understanding of your data. And better yet, the Nova multimodal embeddings model does this all with industry-leading precision. But now, having a great embedding model is only part of how we're enabling you to use vector search on your data. You see, the real magic happens when the vector search capabilities are available on all of your data, wherever it lives. If you think about how your teams work today, they're already deeply invested in specific databases and analytics platforms. And when vector capabilities are built directly into these services, a couple of great things happen. First, they don't need to invest time and energy to learn a brand new vector database. And you don't need to pay for something entirely new. So you get agility and cost savings. And this is why at AWS we're approaching vectors the way we approach everything, with both breadth and depth of capabilities.
Otra base
You
de datos
don't
nueva.
need to learn an entirely new technology stack or manage a complex data pipeline. We've integrated vector capabilities across our services. Let's take a look at OpenSearch. Now, Amazon OpenSearch has long been a backbone of search and analytics, and it's well known for its exact match capabilities. But you're not just looking for exact match capabilities anymore. You want to ask questions in natural language and get intelligent responses. But that doesn't mean you want to give up the ability to run an exact match search either. So today, OpenSearch has evolved into a vector-driven intelligence engine. With OpenSearch, you don't have to choose between a traditional keyword search or a semantic search. Hybrid search gives you the keyword-based precision, and semantic search allows you to get even better results. Now, you're probably thinking OpenSearch is a fairly obvious place for us to add vector capabilities, and I'd agree. In fact, we've added vector search capabilities to most of our database and analytics services. But we've also asked, what would it mean if we brought the power of vector search to our largest data service? And with S3 vectors, we brought the cost structure and scale of S3 to vector storage. And this actually did surprise a few people, even those that know vectors quite well, because this isn't easy. What's great is you can create a vector index the exact same way you can create an S3 bucket.
Y esto es
And this
barato.
enables you to build vector databases of
Más
any
barato que
size
OpenSearch.
with the simplicity of storing data in S3. no provisioning, works at any scale. You pay for only what you use. It's that simple. Now, earlier this week, Matt announced the GA of S3 vectors, which included some significant improvements to query performance and scale. It turns out that searching for the closest vector in a high-dimensional space on a massive vector database is really hard. To find the nearest neighbor, the exact nearest neighbor, you essentially have to compare every vector in your database to the search database. And that requires doing lots of math over all those dimensions. Even in a smaller database where you keep everything in memory, this is often too expensive. So instead, you typically employ something called an approximate nearest neighbor algorithm. And there's a lot of innovation in these algorithms today. They're super interesting. They don't guarantee the absolute closest vector, but they do pretty well. And they scale much, much better. But the challenge that we have with S3 is we aren't storing all these vectors in memory.
Como buscamos.
We're storing them in more economical storage with S3. So how can we provide really low latency on search for vector databases that grow into the billions of vectors and need to run on S3?
Esto es lo interesante.
The approach the S3 team developed is to pre-compute a bunch of vector neighborhoods for every vector database. A good way to think about a vector neighborhood is a place where a bunch of related clusters or vectors are clustered, perhaps French bulldogs or cats that destroy their toys. And these neighborhoods are computed ahead of time, offline, so they don't impact your query performance. And every time a new vector is inserted into S3, the vector gets added to one or more of these vector neighborhoods based on where it's located. Now, when a user goes to execute a query, a much smaller search is done to find the nearby neighborhoods. This is then just the vectors that were in these vector neighborhoods are loaded from S3 into fast memory, where the team then applies an approximate nearest neighbor algorithm. And this can all be done quite quickly, and it returns really good results. How well does this work? Turns out really well. We're seeing sub 100 millisecond query times with vector databases with 2 billion vectors in production. That's the scale and performance of S3 vectors, and it's going to open up all sorts of new use cases for customers. The response to S3 vectors has been great. In just 4 months since we put it out in preview, over 250,000 vector indexes have been created. And we've ingested more than 4 billion vectors and performed over 1 billion vector searches. Now, this type of adoption tells us we're onto something and we're solving a real customer problem. And one of those early customers is using S3 vectors to understand video the way humans do. Please welcome to the stage Jay Lee, CEO and co-founder of 12 Labs.
11 labs, 12 labs.
Thanks for having me, Peter. I'm incredibly excited to be here today. So excited. In fact, I wanted to watch all of Peter's past keynotes to prepare. But to be honest, I've been really busy running 12 Labs and needed help. So I decided to have our models watch the keynotes for me. I indexed over 12 hours of Peter's keynotes from the last 8 years and asked our models to analyze them, to pick out the key insights, to learn more about him. First, I asked, what are Peter's favorite topics to talk about? That's a lot, and I learned really quickly that these are his favorites. Then I searched for the clips where Peter is talking about these topics, and it was really easy for me to find and watch specific clips from each of his keynotes. Now, what started as a fun way to do my research was actually a perfect example of what 12 Labs does every day, turning hours of video into structured intelligence. We're living in a world where about 90% of data today is unstructured. And most of that, by far, comes from video. But even though video is the biggest source of data, it's also incredibly complex. It combines visuals, audio, movement, and most importantly, time. Now, combine that across petabytes of footage in industries like media, entertainment, law enforcement, and enterprises of every kind. That's millions and millions of hours of video. Did you know that 1 million hours of video is equivalent to 114 years if you watch this straight through? The scale is absolutely staggering. And finding meaning in it, finding the moments that matter, is even harder. At 12 Labs, we're building foundation models that understand video the way humans do, not as a sequence of frames or transcripts, but as a unified story across sight, sound, and time. Our models, Marengo and Pegasus, power some of the heaviest multi-petabyte scale video AI workloads in the world, running inference on millions of hours of video. Marengo is our multimodal embedding model that powers precise video search and retrieval. Our latest version, Marengo 3, allows you to find the moments that matter across your massive archives using any-to-any modality search. Pegasus, our video language model, turns video into insights. It performs deep analysis and excels at generating text like summaries, captions, or metadata to power downstream video workflows. Now, we like to say 12 Labs was born on AWS. From the beginning, the AWS startup programs and credits literally changed our trajectory. Those credits didn't just help us train models, they gave us the momentum to productize our research.
Y al menos muchas de las inteligencias artificiales que usan video y eso usan el transcript, por ejemplo, de YouTube. O primero generan el transcript y después trabajan en el video.
The backbone of our data infrastructure is on Amazon S3. When a customer sends requests to one of our model APIs on the 12 Labs platform, the system seamlessly ingests, indexes, and embeds video at petabyte scale without ever moving their data out of S3. Now, with as capable as our models are, they require equally competent vector storage. What unlocked innovation for our Marengo model was the integration of Amazon S3 vectors to deliver an optimized video intelligence offering at scale. Now, vectors are at the heart of what we do. Each scene, audio segment, text cue, and video gets encoded by Marengo into a multidimensional vector embedding that captures semantic meaning across space and time. Now, what does that look like? Let's assume for a single hour of video, that's thousands of vectors. Now, but we're talking about customers processing millions of hours of video. That's billions of embeddings. Whoa. These embeddings flow directly into S3 vector indices. No data migration, no re-architecting the infrastructure. The same S3 buckets already storing the source video now store the embeddings that make it searchable with the same durability and scalability guarantee. For example, when a user types a natural language query, like people watching a space shuttle take off from a distance, the query gets embedded by Marengo into the same vector space. S3 vectors then performs an approximate nearest neighbor search across billions of stored embeddings and returns video results with metadata like video IDs and timestamps that pinpoint the moment that matter, the moment that match the query. From there, our customers can take these video results and use them to power downstream video tools and workflows. Now, one of our customers, ArcXP, is a perfect example. An extension of the Washington Post, they provide a media management platform powering news organizations around the world. Built on S3, ArcXP enables editorial teams to not only store and manage their massive archives, but now they can personalize the stories they create with it. Now, a single video or article can be transformed into tailored variations for different audiences. They leverage 12 Labs models to quickly analyze and enrich archived video content and discover related clips to build new stories. That is what accessibility means to us. Not just APIs, but infrastructure on AWS that makes video intelligence viable at any scale. Our partnership with S3 enables us to deliver an incredibly efficient product offering directly to our customers' infrastructure. Now, given the scale of the data we handle, that has a meaningful impact on our customers' unit economics, which unlocks new possibilities. I started by telling you I used our own models to prepare for this keynote. That's not just a demo trick. For decades, video has been a write-only medium. But now we capture everything, every game, every meeting, every moment, but we couldn't find it, learn from it, or build on it. Today, that's changed. We're turning the world's video into knowledge that's actually usable. Every organization has their own version of Peter's keynotes. Institutional knowledge trapped in video. Footage that could teach you something if you could only ask it a question. And now you can. We can't wait to see what you
Necesito poner todo mi
Thank you.
contenido ahí. No, pero está bueno eso, de poder trabajar directamente con el video, porque hay mucho video que no tiene texto, no tiene nada, y...
All right. Earlier, Dave covered the work we're doing with Graviton to lower cost and improve performance. And there's no place we're making deeper investments in our infrastructure than supporting AI workloads. And the reason's pretty easy to understand. AI workloads are growing explosively, and running these workloads is expensive, power hungry, and capacity constrained. And that's why we built Trainium. Trainium supports almost every imaginable AI workload. Our naming convention is not ideal, but as you've heard, Trainium is optimized for both training and inference. And if you're using Anthropic's models, whether from Bedrock or from their 1P, you're probably already benefiting from Trainium. Trainium supports the full spectrum of model architectures, from dense transformers to mixture of experts to state space models. And it supports all sorts of modalities, text, image, video, you name it. Simply put, Trainium can handle every AI workload that you want to run today and anything you can imagine building. And Trainium supports all these workloads with great performance. Performance can mean lots of things. It can mean building the largest training cluster like Project Rainier, or it can mean processing an inference request and generating your answer as quickly as possible at the best possible efficiency. There's lots of ways to optimize
Más de
performance,
chips.
but Trainium gives builders the tools to deliver great performance with their models and applications. And Trainium supports these workloads at meaningfully lower cost. As you've heard this week, Trainium 3 will provide up to 40% lower cost than even the most demanding AI workloads. 40% lower cost. That's a big deal when you're spending tens of billions of dollars on infrastructure. Let me show you a little bit more about how we're achieving this. Okay, this is our second generation Trainium Ultra Server. An Ultra Server is where we combine lots of Trainium servers into a single AI supercomputer. And this second generation is a significant step forward from the first generation we launched last year. First, it's based on Trainium 3 chips, and lots of them. There's 144 Trainium 3
Solo
chips across
lanzaron
2 racks, combined into a single Ultra Server.
Esta semana.
But I want to draw your attention to the devices in the middle of these racks. Those are Neuron switches, and they're used to interconnect all the Trainium 3 chips in this rack to create that one massive AI supercomputer. But these are not your typical network switches. These switches are specifically designed to provide full bisectional bandwidth at extremely low latencies directly to those Trainium chips. So what kind of performance can this provide? Well, the key performance dimensions that matter in AI supercomputers are compute and memory. And this Ultra Server has a lot of both. 360 petaflops of 8-bit precision floating point compute, and 20 terabytes of high bandwidth memory with 700 terabytes per second memory bandwidth.
Una locura.
That's 4.4 times higher raw compute performance and 3.9 times more bandwidth than last year's Trainium Ultra Server. And this makes it one of the most powerful AI supercomputers available, allowing us to run or build even the very largest models. Let's take a closer look. These are just sticker stats, and those of you that heard me You have to look deeper than the sticker stats. So let's take a closer look at the Trainium 3 server and chip to understand how they're able to deliver great performance and differentiated cost. Okay, this is one of the Trainium sleds. You could pull this right out of the Ultra server. There's 36 of these sleds interconnected with all those neuron switches in one of those Ultra servers. Now let me point out a few really cool things. First, this represents our first system where we use all 3 AWS custom designed chips on the same server board.
Mira.
You'll see the 4 Trainium 3 accelerators are located on the far end of the board. And right next to those is a Graviton processor. Now, Graviton gives us the high-speed I/O necessary to keep these accelerators busy. And by having Graviton co-located on the same sled as the Trainium, we avoid the need for a dedicated head node in our rack. And that gives us additional space to build an even bigger Ultra server. Additionally, having that Graviton server there lets us do maintenance on just this one sled without taking the other sleds out of production. And that has the benefit of keeping our capacity where it should be, in production, running your code. And speaking of maintenance, another key differentiator you can see here is everything is top serviceable on this sled. This is unique with an AI server, and this design pays dividends in a few ways. First, it enables entirely robotic assembly of the server, and that lets us put these Trainium chips into our fleet faster. And second, when we need to service these systems in production, we can do it quickly and efficiently. Okay, finally, you'll see that we have 2 Nitro cards to provide very high-speed networking. Nitro enables EFA, or Elastic Fabric Adapter, which enables Trainium servers to share memory over with thousands of other Trainium servers, directly reading and writing from each other's memory over encrypted channels with built-in network multipathing and fault tolerance. Now, that's exactly what you need if you want to build a massive training cluster and build a big model. Of course, building a great system is only part of the story. You need a great chip. Dave talked about this earlier this morning, but you don't just wake up one morning and decide you want a great chip. Building a great chip is the result of relentless execution over a long period of time. And that's what we've been doing with Trainium. We've been working with our customers, internal and external, for many years. Every time we build a new chip, we learn from how customers use it, and that learning fuels our future generations, a cycle of customer-driven innovation. And we
¿Será el
don't focus on
competidor de
benchmarks,
Nvidia
we
esto?
focus on real customer workloads and find innovative ways to make those workloads more productive. So, what does that look like on Trainium? We've added a number of micro-architectural capabilities to Trainium. Optimizations like this don't show up on the sticker. But all of these new optimizations make Trainium run more efficiently, solving common machine learning problems. Take microscaling, which allows you to use lower precision floating point numbers while preserving the accuracy of the models, the larger parameters. Or faster softmax, or tensor dereference, or background transpose. These optimize common AI computing problems and free up the compute engines to do other work. Or take things like traffic shaping, memory add write, memory hash spraying. These make your memory and network more efficient, and that keeps your Trainium chips fed with the data. Because while AI chips might provide hundreds of petabytes of floating point calculations on their spec sheet, that only matters if you can keep the data flowing into the compute engines. Now, almost every AI workload that we're aware of will benefit from one or likely multiple of these new chip capabilities. And this is a good time to mention that it's not just about having the best chip or the best hardware. You need the right tools to build on that hardware. And this is a place we're investing deeply to differentiate Trainium. For customers looking to extract every bit of performance, they need to control things like scheduling, memory allocation, pipeline depth to maximize the performance of their workload. Our solution here starts with NICI, or the Neuron Kernel Interface. It's a language that combines the simplicity of matrix operations with direct instruction-level access to all of Trainium's hardware capabilities, all done inside a familiar Python programming environment. Those features we just looked at are all accessible from Nikki. Take Descartes AI, for example. That's the company that built the cool application that turned me into a cartoon of Werner earlier this morning. That was running on Trainium 3. Descartes AI used Nikki to optimize their real-time video generation models on Trainium 3 and reported drastically faster performance on Trainium 3 than any other hardware platform they tested. And they told us the optimization process with Nikki was quick and intuitive. Now, they're going to be up on stage in a minute to tell you more about this. Which brings me to today's update on Nikki. Nikki's going to be generally available in Q1. And we're really excited to get this powerful tool in more of our customers' hands. We're also open sourcing all aspects.
¿Esto será la competencia de CUDA?
Nothing is worse than a compiler surprising you when you're working. And so having complete visibility into the compiler and the code stack is going to make it even easier for you to get maximum performance from the hardware. Now, if you've ever worked on deep performance engineering, you know that your best friend is strong coffee and a great profiler. A profiler lets you see what's happening on the hardware in detail. Where are the bottlenecks? Where should I focus my attention? That's exactly what we provide with the Neuron Profiler. But here's what makes it special. Trainium has dedicated hardware capabilities on the chip for profiling your code without impacting performance. And this means you can profile actual production code running in a real environment. And you can get instruction-level precision. So that means you have all the information you need to optimize your code. And today, I'm excited to share that we've taken it one step further with Neuron Explorer. Neuron Explorer takes all that detailed profiling data and it presents it in an intuitive interface that makes it easy to understand what's happening and to identify opportunities for improvement. In fact, Neuron Explorer automatically detects your bottlenecks and suggests optimizations. This allows you to spend more time fixing things and less time hunting for problems.
No encuentro ninguno de estos anuncios
We've
todavía.
looked a lot at how we are investing for great performance for Trainium 3 and the tools you can use to achieve that. But let's look at those actual performance numbers. Here's the open source GPT OSS 120 billion parameter model from OpenAI running on both Trainium 2 Ultra servers and Trainium 3 Ultra servers. Now, as I mentioned, the Trainium 3 Ultra server has 4.4 times more compute than that Trainium 2 Ultra server. So to make this a fair fight, we normalized everything to output tokens per megawatt. And look at these gains. 5x higher output tokens per megawatt while maintaining the same user visible latency. This should give you a sense about why we're so excited about Trainium 3. By the way, for those of you interested in going deeper, we'll be open sourcing this code, including the relevant Nikki kernels, so you can learn from it and reuse it. I've covered a lot about how we've built Trainium to run any AI workload you can throw at it, and how we're working to make it possible to get differentiated performance and lower cost with Trainium. But we have been working on one more really important thing. That's making it easy for everyone to use Trainium without having to learn a whole new chip and a whole new programming language. And that's why I'm thrilled to share that Trainium is becoming PyTorch native. What does this mean? Well, let me show you. We'll port some code. Okay, here's the code that's running our model on our trusty NVIDIA GPUs. Now, if we change the simple line from to CUDA to Neuron, we're ready to run on Trainium. That's it. That's all it takes. Now everyone, researchers, students, even Dave, can use Trainium without having to run a brand new software stack.
Era la competencia de CUDA nomás.
This seamless integration is made possible by phenomenal work from the PyTorch team, allowing us to support different backends. We already have this working with some customers, and we expect to release it broadly early in the new year. Of course, the most exciting thing about building chips is getting them in our customers' hands. And with Trainium 3, we're delighted with the early feedback from our customers. And our partnership with Anthropic is a great example of our deep collaboration with customers that's helping us produce leading AI accelerators. But we're also excited about some of the innovative startups that are doing new and exciting things with Trainium. Right now, I want to bring one of those customers on stage, already building with Trainium 3 and Nikki. Please join me in welcoming Dean Lettersdorf, CEO of Descartes.
Este es el de la animación del principio.
Thank you, Peter. And it's exciting to announce what we've been working on together. Today, I'm going to show you something that's completely new, something the world hasn't seen before. It's a new category of Gen AI foundation models called real-time live visual intelligence. Take a look at the screens to my left and right. We're all here right now at reInvent, but what if we wanted to be all powered up? Earlier, when Peter walked on stage, he looked like Werner, and that was our models, our Descartes foundational models, running on Trainium 3 live. Every pixel you see right now is being generated on this stage in real time.
Filtros de Snapchat.
At Descartes, we're an efficiency-first AI research lab, and we're building foundational models for visual intelligence. Vision is how we see the world. It's how we communicate. It's how humans understand each other. And it's how robots will be able to understand our world, to train themselves in generative simulations. This is what video and world models are all about. And it's happening right now, live, because for the first time, we could take foundational models for LLMs and video diffusion models and get them to run at the same time with zero latency. Trainium 3 has been a huge enabler for our workload in creating this new Gen AI category of real-time visual intelligence. At Descartes, we have a lot of proprietary IP that allows us to train and inference models much faster and more efficiently. And we work closely with the AWS team to port our model stack, to port our infrastructure to Trainium, to let us work with Trainium for building models and running them. And we optimized it all using Nikki language, which Peter just talked about. And it made the transition just much faster than what we expected. I'm talking that we're on a path to getting to 4x better performance in frames per second than what we can do in state-of-the-art GPUs. It's 80% tensor core utilization. These are metrics we just don't hear of in AI. Now, the reason we get this performance, it's a result of how we combine Trainium and our models. So the models that we train at Descartes, they have three components. An LLM that does reasoning, understands the world. A video model that understands pixels, that understands structure. And an encoder that lets all of the two connect and run together. So usually we have to run these in sequence, one after the other. But we're able to build a Trainium megakernel that we wrote, and it got it to run all three at the same time with zero latency on the same chip, achieving maximum HBM memory utilization, tensor engine utilization, all at the same time with no latency. We're already seeing how our models are changing how we behave online. On Twitch, we have streamers that create new compelling experiences with their audiences. In shopping, imagine you see this cool lamp, and before you buy it, you see it. Next time you watch a movie, it gets placed in that movie just for you. We're trying to make sure that every product, before you buy it online, you can try it on yourself in your home, see what you feel about it, see how it looks. One of the experiences I love most is basketball. So you're watching the game, and to keep your kids engaged, you let them watch the Descartes AI cartoon version, which is being generated live from the match. We're taking AI, and we're putting it into live sports in the arena, in your living rooms. For gaming, we're creating a completely new foundation. It's games that generate themselves as they're being played.
Una locura.
And frankly, everything you just saw, all these experiences, we didn't come up with them. It was builders, it was developers that took our API. You guys know your industries way better than we do, and you can understand how to take these models and extract value out of them for your customers, for your industries. If we step into the future, step a few years into the future, I really believe in taking this tech to robotics and simulations. Robots are already using models like this to envision infinite possibilities, infinite outcomes on the road, in homes, factories, manufacturing. And in the future, we'll be able to train robots fully in generative simulations before they ever hit the ground. And when they hit the ground, they will use live visual intelligence to understand the world around them, to understand the human environment. I'm really excited to be here and announce with AWS this new category of Gen AI live visual intelligence. We're taking it to every industry, every market at any scale, powered by Trainium 3 using the CART models.
Yay.
Everything we build, we put it down our API every few weeks. We launch it at our mobile app. And the world is shifting. For the first time, we can take stuff that's in our imagination and connect it to what we see with our eyes in reality live. I really can't wait to see what all of you build with it. Thank you all.
Interesante.
All right. Thanks, Dean. Well, we started out this morning by asking what AI means for our infrastructure. And after everything we've explored, I hope the answer is clear. The fundamentals matter more than ever. Security, availability, elasticity, agility, cost. These aren't relics of a pre-AI world. They're the foundation upon what the future applications will be built on. The investments we've made from Nitro to Graviton to Lambda weren't just about solving yesterday's problems. They were about preparing for exactly this moment. Today, you saw what that preparation looks like. Graviton 5 delivers 192 cores and a big old cache. Lambda managed instances, expanding the meaning of serverless. Vectors becoming the connective tissue of your data. And Trainium 3, bringing great performance and lower cost to every AI workload you can imagine. But here's what excites me the most. It's still day one with AI. There's gonna be twists and turns that none of us can predict. New architectures will emerge, new possibilities will unfold. And AWS will be here, just like we've been for the past 20 years, removing constraints, providing building blocks, and helping you navigate whatever's next. So what will you build next?
¿Qué van a
But first,
construir?
remember, don't miss the closing keynote with Werner. Thank you, and enjoy the rest of your week.
Yay. Y esa fue la keynote. Creo que de las keynotes que vimos es de las más educativas. Así que espero que hayan aprendido un montón. Al menos es muy difícil reaccionar a estas keynotes porque no quiero interrumpir a estos personajes hablando de cosas tan interesantes. No anunciaron nada, pero no es el objetivo de estas keynotes. Pero bueno, si les interesa ver los anuncios de toda la semana, están en el blog de What's New. Acá pueden encontrar todos los anuncios. Este blog es como el Release Notes de AWS y también en el blog de AWS News Blogs. Acá tienen un post con los anuncios más tops de re:Invent y están todos categorizados. Y si no, los espero el lunes en la newsletter de desplegando.cloud, donde les voy a dar mi take en mis launches favoritos de re:Invent, si no quieren leer todos esos artículos. Y como les comentaba al principio, si quieren mirar, están ya como... Vamos a ver cuántas sesiones de re:Invent han subido, 246. Están todas subidas a las breakout sessions a YouTube para que las puedan consumir. Y como les mostraba, habían hecho esta página donde podés hacer tu playlist y mirarlas con un poco más de orden. Así que estas ya se las copié al principio, pero se las pongo acá. Y no sé, me gustaría saber que... Creo que ya dijeron más de 100 veces la palabra IA. Yo creo que más. Si alguien estaba haciendo un shot cada vez que decían IA, en este momento está muerto o en el hospital. Espero que nadie haya hecho eso, porque hasta tomando agua te podés morir con tantos tragos. Eh, pero bueno, me gustaría saber que hay gente que la he visto en los 3 vivos. ¿Qué opinan? ¿Es algo que hay que hacer más seguido, aunque no sea de Reinvent, de otras cosas? Hacer vivos y charlar es algo que les copa. Yo, si no tengo nada que decir, me cuesta mucho venir a hacer un vivo. Soy más de grabar y hacer contenido editado. Pero bueno, me pareció como divertido venir y charlar un rato con ustedes y ver la keynote juntos, al menos las 3 keynotes, porque yo las veo siempre y, como ya les dije, en mi casa a nadie le importa lo que dicen estos señores, solo a mí, y no tengo con quién comentarlo. Pero bueno, capaz algún vivo en algún otro tema, hablando, no sé, de algo. No les prometo nada, porque tengo que pensar, pero bueno, me sorprendía la cantidad de gente que vino a esto. Yo pensaba que iba a estar yo sola. Así que bueno, muchas gracias por estar acá. Y y, y les cuento, bueno, acá Miguel Luis Miguel es de la comunidad, que es lo que... Las keynotes de Werner Vogels suelen ser las mejores, en mi opinión, pero a mí me caen a la 1:30 de la mañana. Entonces, si sos desarrollador o persona de DevOps o en esos roles, te van a copar, porque generalmente habla de buenas prácticas de software, de buenas prácticas de ingeniería, ataca problemas de los desarrolladores, así que totalmente recomendable. Yo la veré mañana cuando me levante. Mientras estoy en la caminadora del gimnasio, veré la keynote. Capaz que no toda, porque no voy a correr 2 horas, pero un rato. ¿Dormir está sobrevalorado? No. Dormir no está sobrevalorado. Se pueden ver luego, tranquilamente. A mí nadie me dice mañana, a las 8 de la mañana, ¿qué dijo Werner? No. La veré mañana tranquilamente. Pero si estás en Vegas, sí tenés que ir a verla si podés. Pero para verla por internet, la veo mañana tranquila. Nada, les comentaba que Miguel, que dijo que está en la comunidad, y les quería contar un poquito de la comunidad para los que me han preguntado. Es una comunidad donde estamos charlando y haciendo planes de estudio, trabajando, estudiando juntos para aprender de AWS. Así que es si les interesa aprender o empezar su carrera en AWS o saber más, sobre todo de serverless y IA, que es lo que está de moda, pero sobre todo serverless, y desarrollo de aplicaciones y construcción de software orientado a... Esto está muy orientado a los desarrolladores, a la gente de operaciones, que quieren aprender a hacer aplicaciones en AWS. Bueno, vamos a hacer todo tipo de actividades. Tenemos eventos, tenemos cursos, hay planes de estudios que yo creo que es de los más interesantes, donde vamos de la manito haciendo proyectos propios. Así que si es algo que les interesa, les dejo ahí un código de descuento. Ese código está disponible hasta la semana que viene, el lunes creo. Así que si quieren mirarlo, pueden ir, mirarlo. Y cualquier consulta me preguntan. En todos los videos pueden encontrar mi correo electrónico o en las redes sociales, y encantadas de ir comentándoles y respondiéndoles las dudas. Pero es una comunidad muy bonita, y ahora arrancamos un curso de Lambda nuevo que está en formato calendario de Adviento, así que está divertido. Y en enero vamos a empezar con un curso de automatización de procesos con Step Functions e inteligencia artificial, que va a estar súper bueno. Serán como 6-7 horas de contenido. Debe ser de los contenidos más profundos que hay de Step Functions, y va a estar todo en español. Así que bueno, eso les quería comentar por un lado. Y bueno, con eso yo creo que ya terminamos los vivos. Nos podemos ir a hacer nuestra vida. Yo me voy a ir a cenar. El resto de la gente capaz a almorzar, tomarse un café, mirar por la ventana y disfrutar la vida, estirar las piernas. Muchísimas gracias por acompañarnos hasta el final y estar todos juntos acá mirando la Keynote porque no vamos a reinvent y con alguien tenemos que charlar. Así que gracias y nos vemos la semana que viene en un video que voy a subir que va a estar muy bueno. Lo estoy editando ahora. Espero que les guste y déjenme ahí un mensajito. Muchas gracias y nos vemos. Chao, chao.